In question number 3, we have in figure 6.20, if LM parallel CB and LN parallel CD, prove that AM by AB equal to AN by AD. So this is the figure that we have got from this question. According to this question, we will prove AM by AB equal to AN by AD. So to prove this, first I will take two triangles from this figure, ABC and ADC, and I will apply Thales theorem or BPT theorem. In triangle ABC, LM parallel CB. LM parallel CB, this given in our question. In triangle ABC, LM parallel CB. If this LM is parallel with CB, then I can apply Thales theorem or BPT theorem. In Thales theorem, we know that when a line is parallel to one side of a triangle, then the remaining two sides ratio become equal with each other. So I will write here using Thales theorem. AM by AB equal to AM by AB equal to AL by AC. AL by AC. So give this equation number 1. Now again you take this triangle ADC. So in triangle ADC, LN parallel CD, this is also given in our question. So write here LN parallel CD. Now here also I will apply Thales theorem. So using Thales theorem, AN by AD, AN by AD equal to AL by AC, AL by AC. So give this equation number 2. Now comparing this equation 1 and 2. So from equation 1 and 2, AM by AB equal to AL by AC and AN by AD also equal to AL by AC. So same ratio I have got here, means I will compare now this and this. AM by AB equal to AN by AD, and this is our proof. AM by AB equal to AN by AD. So hence proof. Now we'll do for question number 4. So in question number 4 we have in figure 6.21, DE parallel AC and DF parallel AE. Prove that BF by FE equal to BE by EC. So I will take two triangle from this figure. This is the figure that I have got from question. Now from here BAC and BAE, these two triangle from, I will compare the ratio. So right here in triangle BAC. So in BAC, given here DE parallel AC, means DE is parallel with AC. So right here DE parallel AC. If DE is parallel with AC, then I can apply in this triangle, I can apply Thales theorem. So using Thales or BPT. BPT means basic proportionality theorem. Either you write Thales theorem or BPT theorem. So using BPT, I can write BD by DA, BD by DA equal to BE E by EC. B E by EC. Give equation number 1. Now next triangle is BAE. So BAE. Now in this BAE, DF parallel AE, this given in our question. So right here, DF parallel AE. If these two lines are parallel with each other in this triangle, then here also I can apply BPT. So using BPT. So now you compare the sides ratio. BD, so right here BD by DA equal to BF by FC. So right here BF by FC. So this you give equation number 2. Now from equation 1 and 2. BD by DA equal to BE by EC, and here also we have BD by DA equal to BF by FC. So common side, these two are equal with each other. I can write from this two equation, I can write BF by FC equal to BE by EC. Hence proof. Now we'll do for question number 5. So in question number 5 we have in figure 6.22 DE parallel OQ and DF parallel OR so that EF parallel QR. This is the figure that we have got from question, and according to this question EF parallel QR, we will show these two lines are parallel with each other. So to show this parallel with each other, I will take two triangle from this figure. Means one I will take POQ and another I will take POR. So in triangle POQ, DE parallel OQ, this given in our question. DE parallel OQ. So right here DE parallel OQ. If DE parallel OQ, then I can apply in this triangle, I can apply Thales theorem. PE by EQ. So right here PE by EQ equal to PD by DO. PD by DO using BPT. This you give equation number 1. Now again I will take another triangle, and this is POR. So write in triangle POR. Here given DF parallel OR. DF parallel OR. So right here DF parallel OR. If these two lines parallel with each other, then here also I can apply BPT theorem. So PF by FR, PF by FR equal to PD by DO. So PD by DO using BPT. This you give equation number 2. Now you compare this equation number 1 and 2. So from equation 1 and 2, I can write PE by EQ. PE by EQ is equal to PF by FR. P by EQ equal to PF by FR, because both sides we have the same sides ratio, PD by DO, PD by DO. So I can write this. And if P by EQ equal to PF by FR, then I can say therefore EF is parallel with QR, and this is converse of Thales theorem. Converse of Thales theorem. Now we'll do for question number 6. Now in question number 6 we have in figure 6.23 A, B and C are points on OP, OQ and OR respectively such that AB parallel PQ and AC parallel PR so that BC parallel QR. We have to prove BC parallel QR means this BC line is parallel with this QR line. So to prove these two lines equal with each other, I will take two triangle. In triangle POQ, here in question already given AB means AB parallel PQ, AB parallel PQ. So write here AB parallel PQ, and if AB parallel PQ, then I can apply here also I can apply Thales theorem. This line is parallel with this third side of this triangle. This is one triangle and this is one side and this is another and this is third side. If this line is parallel with this side, then I can compare the side ratio by using Thales theorem means OA by AP. So write here OA by AP equal to OB by BQ. OB by BQ using Thales theorem or BPT theorem. So give equation number 1. Now similarly, I'll take this triangle POR. So right here triangle POR. Already in question given AC parallel PR means AC is parallel with this PR line. So write this AC parallel PR. And if these two lines are parallel with each other, then I can apply here also I can apply Thales theorem means OA by AP, right? OA by AP equal to OC by CR. OC by CR. Here also write using BPT. This you give equation number 2. Now you compare equation number 1 and 2. So from equation 1 and 2. OA by AP, here also we have OA by AP. And right hand side we have got here OB by BQ and here we have got OC by CR. So these two you compare. This common ratio don't write, just you write these two ratio. OC by CR equal to OB by BQ. Now you check this OC by CR means OC by CR equal to OB by BQ. If these two sides ratio equal with each other, then this BC is parallel with QR. This is converse of Thales theorem. Therefore, BC parallel QR. Hence shown. So finally, I have completed the solution for this question. Thank you.